Okay, next up we want to calculate the Lewis structure for H2CO. And so as usual, let's count our valence electrons. And so we're going to have 2 by 1 from the hydrogens, plus 1 by 4 because of the carbon, plus 1 by 6 because of the oxygen. And this is going to give us 12 electrons to distribute. You can go ahead and label all of these valence electrons. H2, C, O. And so now let's go about drawing a skeleton structure. And so let's place the hydrogens around the carbon and then the oxygen on its own. Typically, we like carbon as the central atom. It can make the most bonds. So in this scenario, it is our central atom. We know the hydrogens can only make one bond. And then let's go ahead and put one bond between these two and fill in our valence electrons. And let's see if, fill in our octets. And then let's see if we get 12. We have 6 from the oxygen plus 2 from the carbon, plus 2, 4, 6 caught in bonds, so 3 by 2 in bonds. And that is going to give us 6 plus 2 plus 6, and that's 14 electrons. So we have an extra 2 electrons here that we don't need. And so the best way to fix this is going to be, let's put a double bond between these two here in order to get rid of 4 electrons and add an extra 2 because of the bond. And so again, let's count our valence electrons. We have 2, 4, 6, 8, 10, 12. Perfect. And all of the octets are full here. Oxygen has its 2, 4, 6, 8. Carbon has its 2, 4, 6, 8. And hydrogen likes 1. Let's check our formal charges. So on carbon, we are going to have 4 minus 8 over 2, which is going to give us 4 minus 4, which is 0. On the oxygen, we'll have 6 minus 4 over 2. That's going to give us 6 minus 6, which is again 0. And lastly, on our hydrogen, we are going to have 1 minus 0 minus 2 over 2. That's just going to be 1 minus 1, which is 0. And this is exactly what we had expected, to have a net formal charge of 0. And so our formal charges are happy and our valence electrons are happy too, which means that this is going to be our final answer. And so they would like one with dots and dashes and one with dots only. So if we have dots only, we'll have 2 electrons in the bond there, 2 electrons in the bond there, 4 electrons in the bond there, oxygen, and it's 4 valence electrons. So this would be the dot structure.